गुड मॉर्निंग एवरीवन, वेलकम टू गेट एकेडमी। सब लोगों को नमस्कार। आज हमारा सेशन लेक्चर नंबर 4 स्टार्ट हो रहा है। एक बार चेक कर दीजिए आवाज, इज मेरा साउंड एंड एवरीथिंग इज क्लियर, साउंड एंड वीडियो। चलो राइट। चलो, so we'll wait for just for 10 more seconds. Let all the students join. Let all the students join. So कल हमने शाम को 7 बजे से 9 बजे तक कैपेसिटिव ट्रांसड्यूसर्स एकदम सेशन कंप्लीट कर दिया। आई थिंक ऑल ऑफ यू हैव एंजॉयड द सेशन, इंस्ट्रूमेंटेशन के लोगों। सो आज हम स्टार्ट करने वाला है और एक इंपॉर्टेंट सेशन, पीजोइलेक्ट्रिक ट्रांसड्यूसर्स। सो जल्दी से जल्दी आप थोड़ा बुकलेट ओपन कर दीजिए, क्योंकि ये क्रैश कोर्स है, ये पक्का प्लान्ड कोर्स है गेट एकेडमी तरफ से। एवरीथिंग इज प्रॉपरली शेड्यूल्ड। सो एवरी क्लास एंड एवरी लेक्चर एक एक चैप्टर कंप्लीट करके जा रहे हैं। एक चैप्टर्स का प्रैक्टिस जो कुछ है आपको लगातार आपको अच्छा होगा, गेट में अच्छा रैंक आने के लिए ये प्रैक्टिस यूज होगा। सो जो लोग 4th ईयर स्टूडेंट्स पास्ड आउट स्टूडेंट्स ऑलरेडी गेट का प्रिपरेशन कर रहे हैं, वो लोगों के लिए रिविजन होगा। जो लोग फर्स्ट टाइम दे आर राइटिंग द गेट एग्जाम, दैट मीन्स 3rd ईयर स्टूडेंट्स और 4th ईयर स्टूडेंट्स ऑफ इंस्ट्रूमेंटेशन, फर्स्ट टाइम दे आर राइटिंग द गेट एग्जाम, उन लोगों को भी ये अच्छा यूज होगा। एंड especially for triple E students, suppose if triple E students are planning to write, EC students are planning to write instrumentation paper as a second option, so उसको डाउट होगा सर हमको ये सब्जेक्ट डिफरेंट है, क्योंकि ट्रिपल ई बच्चों के लिए आप सबका सब्जेक्ट्स इक्वल ऑलमोस्ट सेम है। आपके लिए सिग्नल सेम है, एनालॉग सेम है, नेटवर्क थ्योरी सेम है, डिजिटल सेम है, कंट्रोल सेम है, लेकिन ये सब्जेक्ट डिफरेंट है। ये सब्जेक्ट कैसा प्रिपेयर करना, हमारा क्रैश कोर्स पढ़ के भी आप जा सकते हैं। एक क्रैश कोर्स का जो कुछ कॉन्सेप्ट्स है आपको यूजफुल होता है। ओके, स्टार्ट करेंगे। सो लेट अस सी, या सम कमेंट्स आर कमिंग। गुड मॉर्निंग एवरीवन। चलो, क्या कमेंट्स? गुड मॉर्निंग। राहुल जायसवाल, नमस्ते। yesterday also you were present, you are my regular student. Good morning, good morning, good morning, good morning to all, good morning to all. Love you all, love you all. चलो स्टार्ट करेंगे। सो सम ऑफ द पर्सन वाज टेलिंग सर आपका वॉइस अब्दुल कलाम का वॉइस आ रहा है, अब्दुल कलाम की वॉइस की तरफ से आ रहा है। some student has posted a comment, sir your voice is just like Abdul Kalam voice. So thank you very much bhai, but it is a great appraisal to compare me with a great personality Abdul Kalam. So it is not correct, I think, because it is not respectful to that person, great person. He is a very great person. Okay, I'm just we are a normal human beings, but anyway I am thankful for your compliments. I'm thankful for your compliments. Chalo, how many of your instrumentation students here, can you show me the thumbs? Instrumentation के बच्चे, just I'm watching your comments here on the desktop पर। Okay, instrumentation के बच्चे और ट्रिपल ई के बच्चे, EC के बच्चे, please show me your thumbs there. ट्रिपल ई के बच्चे and EC के बच्चे, please show me your thumbs. Good morning Vijay Lakshmi. Good morning. Yeah, Rahul Jaiswal, instrumentation, very good. Please type your branch also, so that it will be very good. Chalo. Right. Nice. Start करेंगे। सब लोगों के पास बुकलेट्स है। All of you have the booklets with you. PDF booklet, I mean soft copy. Yes, it is useful. Anand, it is useful if you are writing gate instrumentation paper as a second option, or if you are preparing for IES. See, I want to tell you about this subject. So this subject actually, see the subject for electrical students, how it is useful. Electrical students के लिए in IES there is one subject called electrical measurements. Actually the title of the subject is not electrical measurements, the title of the subject is measurements and instrumentation. I'm writing in short. इसमें 3 टॉपिक्स होगा IES में. It is not only for triple E, it is also for EC. Okay ना? ट्रिपल ई एंड EC लोगों को मेजरमेंट इंस्ट्रूमेंटेशन 3 पार्ट्स होगा। फर्स्ट पार्ट होता है इलेक्ट्रिकल मेजरमेंट्स, सेकंड पार्ट होता है इलेक्ट्रॉनिक मेजरमेंट्स, थर्ड पार्ट होता है इंस्ट्रूमेंटेशन. Under the electrical measurements, they will study measurement of voltage, current, power, PMMC, moving iron, dynamometer, energy meter, error analysis. So these are the topics under electrical measurements. Electronic measurements के अंडर होता है laboratory instruments like CRO, Q meter, DVM, ऐसा होता है. Next it comes instrumentation. Under the instrumentation will be having transducers. Okay ना? So अगर आपने IES का पेपर लिख रहे हैं then it is useful. And also अगर ट्रिपल ई बच्चे एंड ईसी बच्चे अगर आपने गेट इंस्ट्रूमेंटेशन पेपर लिख रहे हैं एज ऑप्शन टू इफ यू आर राइटिंग देन दिस सब्जेक्ट विल बी यूजफुल. व्हाई? बिकॉज ये गेट इंस्ट्रूमेंटेशन का कोर सब्जेक्ट है. समझ में आपको? somebody was asking, electrical students were asking, can you send the PDF again? I don't see, it's already posted there. Vishwanath Sharma, in that YouTube chat box above Gate Academy channel is there. In that there is a link is there. If you click that link, you can get the booklet there. Okay na? So Gate Academy people will post there. Yeah, biomedical also, very good. So this subject is there for gate instrumentation now, gate biomedical also, and IES को भी है, and EC बच्चे, triple E बच्चे अगर option 2 if you are writing gate instrumentation, that also they will have. It will be useful for them. And one more thing, other than gate, suppose if you are writing non-gate exams like ISRO, electricity board exams, in those exams also transducers is the expected topic. It can be Karnataka Power Corporation Limited, Tamil Nadu Electricity Board, AP Genco, Andhra Pradesh Power Corporation, Telangana State Genco. Okay na? So in all those electricity board papers, the subject transducers will be there. You can check the state syllabus. Clear? Vishwanath, clear? Chalo. Now, today we'll start the next topic, piezoelectric transducer. So, piezoelectric transducer is our one of the important topic. Next topic, piezoelectric transducer. Okay na? So, piezoelectric transducer. Clear hai? Biomedical engineering. Sir, can you send the PDF again? Sir, the PDF is available. PDF is available in the free crash course link. Yeah. Chalo. Piezoelectric transducer. So what is this piezoelectric effect? So why? Because we are having some couple of questions here. If you see in the PDF booklet, we are having some set of questions. So next questions will start from this one. See this question, all of you can watch this question. I think the question is visible to you. Okay. A quartz crystal whose Young's modulus is given with piezoelectric properties has a diameter of 10 mm and thickness of 2 mm. Its voltage sensitivity constant is 4500 volt per micrometer. If the voltage output is 127.3 volts, then the applied load is approximately dash. Can anybody do this question? ट्राई टू डू दिस क्वेश्चन, बट बिफोर डूइंग दिस क्वेश्चन आपको पीजोइलेक्ट्रिक इफेक्ट के बारे में मालूम होना है. सो पीजोइलेक्ट्रिक इफेक्ट क्या है? सी हियर. सो piezoelectric transducers are manufactured by piezoelectric crystals. Piezoelectric crystals. So example of piezoelectric crystal is quartz crystal. Example of piezoelectric crystal is quartz crystal. Quartz crystal का chemical configuration होता है silica 3SiO2. So just before entering into the problem, we'll have a brief discussion about piezoelectric effect. Okay na? All of you fine? Shall we take some brief introduction about the piezoelectric effect and then we'll go for the problems? Bolo Vishwanath, Santosh, Rahul Jaiswal, Parth Desai, सब लोग हम just will have a brief introduction. Reply कीजिए जल्दी, please reply. We'll have a brief introduction of the piezoelectric effect, then we can do the problem. Why? Because piezoelectric effect will have certain formulas, certain important formulas. So if you see this quartz crystal, so generally the quartz crystal का chemical configuration, it looks like a cube. It looks like a cube. Okay na? It looks like a cube. So chemical configuration is 3SiO2. So the atoms are like this. Here comes silicon atom, silicon ion, and opposite comes oxygen ion. Okay na? And next here comes our set of oxygen ion, and here comes एक silicon, and here comes एक silicon, and here comes एक oxygen. So all of are fine? All of are able to see this picture clearly? सब लोगों को दिखा रहे ना ये क्वार्ट्ज क्रिस्टल का? या पार्थ देसाई, यू आर फ्रॉम बायोमेडिकल. हाई परतेशा, आर यू फ्रॉम बायोमेडिकल? आप आपका बायोमेडिकल का दोस्तों के भी ये इन्फॉर्म कर सकते हैं, लिंक भेज सकते हैं, क्योंकि दिस टॉपिक इज देयर फॉर बायोमेडिकल स्टूडेंट्स आल्सो. ओके ना? सो विद द टाइटल ऑफ सेंसर्स एंड बायो इंस्ट्रूमेंटेशन. Sensors and bio instrument. Vishwanath Sharma, you also can inform to your entire CVR team. Why? Because it's a free crash course. Those who cannot afford for the paid course, they can use this crash course. Okay, thank you. Now, so this is silica. So what we call it as silica. First listen here. Silica. It contains 3 silicon atoms. Okay, 1 plus 2 plus 3. This 3 silicon, 2 plus 2 plus 2, total 6 oxygen atoms हो गया. So 3 silicon and 6 oxygen. Okay ना? So 3 silicon and 6 oxygen. That means ये बाहर की तरफ से देखने के लिए क्या होता है? क्यूबॉइड की तरफ से, क्यूब की तरफ से दिखाता है स्ट्रक्चर. Structure will look like cube, but when you connect their center of masses with a line, when you connect their center of masses with a line, if you connect their center of masses with a line, you are going to have a hexagonal structure. Am I right or not? So this hexagonal structure को हम बोलते हैं, this hexagonal structure को हम बोलते हैं lattice structure. क्या बोलते हैं उसको? Lattice structure. This lattice structure is hexagonal. Lattice structure is hexagonal. Lattice structure is hexagonal, just like our benzene. Benzene का structure कैसा होता है? C6H6. आप हमारा applied physics में पढ़ाया. Yes or not? Shubham Mathur, yes, love you. Yeah, if you are understanding, please show me the thumbs, because I am watching your comments and teaching here. आपका जो कुछ comments होता है वो comments हमको morning की coffee तरफ से होता है, morning की coffee. Okay, early morning coffee कैसा होता है? एकदम बढ़िया होता है ना? So we will feel happy. Sir, I am from EEE and this is useful for various exams for us. Yes, Shubham Mathur, मैंने बोला ना अभी, just before the session only, I have told you. If you are from EEE, it will be useful for IES. In IES, we have the transducers. If you are EEE and if you are writing a non-GATE exam like electricity board papers, state ka electricity board, then it is useful. And if you are electrical and if you are planning to write GATE instrumentation as option 2, then also it will be useful. And biomedical को भी useful है, biomedical को भी है. So it's a common subject, and in fact it is mechanical also. In mechatronics, IES mechatronics also, mechanical people को भी ये useful है. IES mechanical people को भी useful है, mechatronics बोल के, mechatronics. So it's a common subject. IES mechanical को है, IES ECE को है, IES EEE को है, GATE instrumentation को है. अभी IIT बॉम्बे की न्यू कंडीशन से GATE EEE को भी है and GATE biomedical को भी है. चलो विश्वनाथ, चलो. Now let us see the fast. We will derive the things. Now this particular hexagonal structure is a reason for piezoelectricity. It is a reason for piezoelectricity. Okay ना? It is a reason for piezoelectricity. कैसा होता है? अगर ये स्ट्रक्चर पर आपने फोर्स अप्लाई किया, देन क्या होता है? एक इंटरेस्टिंग थिंग होता है. एक हेक्सागोनल स्ट्रक्चर है ना, ये फोर्स अप्लाई करने की वजह से द इंटरनल मॉलिक्यूल्स आर गोइंग टू गेट स्ट्रेन्ड. हमको एक फार्मूला है ना, स्ट्रेस कॉजेस सर्टेन स्ट्रेन. व्हेन यू अप्लाई द स्ट्रेस विल क्रिएट सर्टेन डिफॉर्मेशन. इसकी वजह से क्या होगा? वन इंटरेस्टिंग थिंग होगा डियर दोस्तों. ये क्या इंटरेस्टिंग थिंग क्या है? दिस मॉलिक्यूल्स विल स्टार्ट रोल ओवर देयर पोजीशंस. These ions will start roll over their positions. This particular ions will roll over their position. A silicon wants to come down and this oxygen wants to go up. That is the beauty of this particular structure. ये structure सब materials में नहीं है, only in quartz material में है. आपको मालूम है ना quartz crystal कहाँ use करते हैं? Quartz crystal हमारा watches में use करते हैं. Quartz crystal हमारा watches में use कर सकते हैं. ऐसा नॉट. सो अभी क्या होता है? स्ट्रेस अप्लाई करने की वजह से वो इंटरनल जो कुछ आयॉन्स है वो डिस्प्लेस होता है एंड ऊपर का सिलिकॉन नीचे आने की कोशिश कर रहा है. नीचे से का ऑक्सीजन इसका प्लानिंग टू गो टू द टॉप. इसकी वजह से क्या होता है? जो कुछ इसका चार्ज है ना, वो चार्ज लीकेज होता है. वो सिलिकॉन का चार्ज पॉजिटिव इज गोइंग टू बी डिपॉजिटेड ऑन दिस बॉटम सरफेस. This bottom surface is going to be have positive charge and the upper surface is going to have negative charge. That means what? You have applied the force. Let me write. You have applied the force. जल्दी से जल्दी मैं लिख रहा हूँ, derivation को जा रहा हूँ. You have applied the force and you got the charge. Am I right? All of you fine? All of you understanding? Ajay, Anant. Yes, you are from mechatronics, Anant. Anant, you can have this knowledge. Why? Because every year mechatronics में, IES mechatronics में कितना मार्क्स आ रहा है मालूम आपको? 14 क्वेश्चंस आ रहा है. mechatronics से 14 क्वेश्चंस आया. लास्ट mechatronics से कितना क्वेश्चंस आया? 14 क्वेश्चंस आया. mechatronics में 14 क्वेश्चंस आया बेटा. 14 IES में 14 क्वेश्चंस आया. सो इसमें यूजफुल है. Yes, Anant. 14 questions आया. चलो. Now, that's what the beauty, Vishwanath, that was the beauty of instrumentation. सब instrumentation बच्चों को मैं ये बोल रहा हूँ. If anybody is criticizing your branch, please think they are fools. If anybody is criticizing your instrumentation branch, please tell you are fool. Because instrumentation का subject sensor mechanical में है, electronics में है, electrical में है, biomedical में है. सेंसर के बिना दुनिया नहीं है. Now you are able to watch this session because there is camera is sensing my image. This audio is sensing my image and it is given to a YouTube, and from that the data is transmitted by using optical fibers and you are getting the data. Everywhere sensors है दुनिया में, everywhere sensors है भैया दुनिया में, everywhere instrumentation है. बिना इंस्ट्रूमेंटेशन, बिना सेंसर कोई भी कुछ काम नहीं हो सकता है। हमारा इंडिया में हमारा ब्रांच का सिचुएशन ऐसा है। अगर हमारा जर्मनी को गया तो देयर आर 16 डिपार्टमेंट्स ऑन इंस्ट्रूमेंटेशन। इन जर्मन यूनिवर्सिटीज देयर आर 16 डिपार्टमेंट्स। हमारा इंडिया में हालत ऐसा है। आई एम सॉरी फॉर दैट, आई एम सॉरी फॉर दैट। ओके, हमारा ब्रांच का सिचुएशन ऐसा है इंस्ट्रूमेंटेशन का। So, जो लोग इंस्ट्रूमेंटेशन का बच्चा है, if outsiders are criticizing, that's okay, but being an instrumentation students, if you are criticizing your subject, it is very shameful, it is very shameful. Okay, so हमारा स्वधर्म जो कुछ है वो तो बड़ा स्ट्रांग है, क्योंकि जो कुछ बीटेक करने वाला है, एमटेक करते हैं, एमटेक करने वाला है, कोई ना कोई पीएचडी करना है। पीएचडी करना बोलो तो वो रियल टाइम पैरामीटर से स्टार्ट करना है। Anybody, if he is electrical engineer, if he is electronics communication engineer, if he is a mechanical engineer, if he is a biomedical engineer, a biomedical engineer will take the ECG signal from the body and that is connected to an electrode. The electrode output is connected to an instrumentation amplifier, then it is connected to ECG amplifier, then you are getting the display. अरे यार, हॉस्पिटल्स में वेंटिलेटर्स है, हॉस्पिटल्स में ECG मिशंस है, कोई भी हॉस्पिटल को जाओ बायोमेडिकल का सेंसर्स है। Whether you are a EC student, triple E student, mechanical students, कोई ना कोई दिन आप हॉस्पिटल को जाना ही पड़ेगा, कोई ना कोई दिन आप बीपी टेस्ट करना ही पड़ेगा, ECG टेस्ट करना ही पड़ेगा। उस समय आपको रिमाइंड होना है, सतीश सर ने बोला इंस्ट्रूमेंटेशन इज लाइफ। रिमेंबर दैट, रिमेंबर दैट। ओके, आई डोंट टॉलरेट हु आर क्रिटिसाइजिंग एनी ब्रांच, who are, whether it is a management, whether it is a college student, whether it is a faculty, whether it is a IIT. Okay, if you are criticizing any branch, it is not at all good. Every branch is important, equal and equally important, दोस्तों. Yes, and as mechatronics student I can apply for instrumentation, mechanical, electronics. Yes, हमारा यहाँ CSC and EC only sir. हाँ, हमारा इंडिया में क्या है? CSC and ECE, CSC and ECE. हाँ, at least in this corona situation, I think you could have understand what is the importance of biomedical. At least in this corona situation, I think government should open its eyes. What is the importance of biomedical? Hospitals में कितना importance है ventilators का, hospital में कितना important है. So that's why I have chosen this platform to raise my voice. Departments are closing. Many colleges are closing instrumentation branch. And they are taking ECE 120, Triple E 240, ECE section A, section B, section C, Triple E section A, section B, section C, instrumentation का seats कम है. Okay, चलो, okay, little emotional. चलो, now, yeah, let us go for this. Q and force. When you apply the force, आपको charge मिल रहा है. So Q is proportional to force. Q is proportional to force. अगर आपने force proportional nikala, you are going to get one parameter called sensitivity. So just to remember, just to show it as a sensitivity, I have taken an arrow symbol. Don't consider it as a vector. Don't consider it as a vector. Vardhaman Shah, go through syllabus, you will find instrument syllabus has nearly 60% known topics. From this year in CVR, CSE seats are 600 sir. Yeah, 600. Yeah, 600. The people are taking data science, the people are taking IoT, the people are taking machine learning. But remember बेटा, कोई ना कोई दिन सेंसर, कोई ना कोई प्लेस में सेंसर आने वाला है. सेंसर का इंपॉर्टेंस होता है. Thanks Anant, will refer to that surely. चलो start करेंगे. So how much amount of charge you are getting? How much amount of charge you are getting? That is proportional to the force. That is proportional to the force. The more is the force you apply, क्या होता है? The more is the force you apply, the more is the charge. See, just I will go in fast because हमने question solve करना है. Crash course है. Crash course में questions solve करना है. It is not about theoretical course. Just but whatever required for that problem solving I am deriving, so that triple E people, EC people, other students like mechanical also can be benefited. That is my major motto. That is my major motto. The instrumentation students who are already having the subject knowledge, they can directly go for the question. So this is our question. You can take the question and you can start solving the question. Instrumentation का बच्चा जो कुछ है, they can go back and they can start solving the question. ये all previous gate questions है दोस्तों. ये पूरा PVQs है, PVQs of gate है ये पूरा. PVQs of gate instrumentation है. I am discussing PVQs only. Okay ना? So जो लोग आप पहले बार ये lecture सुन रहे, then they can come back and they can attend these particular topics. So अभी देखो, now we got a parameter called D. So D is equal to Q by F. So Q by F means what? How much a charge developed? How much a charge developed by how much force applied? How much force applied? समझ में आपको? So units क्या होगा? Units क्या होगा? Coulomb per Newton होगा. Coulomb per Newton होगा. Coulomb per Newton होगा. So this particular parameter is called charge sensitivity. क्या बोलते उसको? हमने चार्ज सेंसिटिविटी बोलते बेटा. क्या बोलते? चार्ज सेंसिटिविटी. विश्वनाथ, I told you, instrumentation people, you should maintain a separate scribbling pad. You should note down all these formulas in a short form so that all the running notes will be useful when you are revising. When you are revising. Okay na Rahul? Rishikesh. Jai Balaya. Okay. Don't make such type of comments. Okay. या टाइमिंग चेंज्ड, थोड़ा आज के लिए टाइमिंग चेंज है. ओके, आज के लिए थोड़ा टाइमिंग चेंज है बिकॉज आई हैविंग सम अदर वर्क्स. ओके ना. सो डोंट वरी, हमारा रेगुलर क्लासेस होगा, हमारा रेगुलर 7 बजे को होगा. एवरीथिंग रेडी, वेरी गुड, एवरीथिंग रेडी. सो दिस इज अ चार्ज सेंसिटिविटी. चलो नेक्स्ट क्या होता है, लेट अस सी. सो फर्स्ट फोर्स अप्लाई किया, फोर्स की वजह से आपको चार्ज मिला. And remember, this force must be compulsory dynamic. This is also one of the important bit. Piezoelectric crystals में the force आपने apply कर रहे, that must be dynamic. क्योंकि the reason is if force is static, charge will be static. क्योंकि force की वजह से charge आ रहा है. क्योंकि force की वजह से charge आ रहा है. क्योंकि force की वजह से charge आ रहा है. So force applying is creating a charge. अगर force is static, करंट, मुझे करंट चाहिए. करंट इज इक्वल टू डी क्यू बाई डी टी. करंट इज इक्वल टू डी क्यू बाई डी टी. इफ फोर्स इज स्टैटिक, क्यू इज ऑल्सो स्टैटिक. इफ क्यू इज स्टैटिक, करंट विल बिकम जीरो ना. Current will become zero. That's why I need a dynamic force. This is one of the important bit. 1 mark bit, Vishwanath. Piezoelectric crystal is suitable for dash measurements only. Static or dynamic? Dynamic measurements only. The question बार-बार पूछा है, IES में पूछा है, GATE में भी पूछा है. Piezoelectric crystals are best suitable for dynamic. ओके ना. सो अभी डायनामिक फोर्स अप्लाई करने की वजह से मुझे डायनामिक चार्ज आ रहा है. द फोर्स इज चेंजिंग. व्हेन आई से दिस इज द df by dt, when is the df by dt, force is changing with respect to time. Force is changing with respect to time. इसकी वजह से क्या होता है, charge also goes on changing, charge also goes on changing. Then I can have a capacitance now here. It is going to form like a capacitor or not. So you can take this particular plate's surface area, and this gap is nothing but the thickness of the crystal. This gap is nothing but the thickness of the crystal na, and this is nothing but the electric permittivity na, relative permittivity na. So now force की वजह से charge आ गया, charge की वजह से क्या होता है, capacitance होता है. So capacitance का formula I am writing here. Capacitance का formula, capacitance of the piezo is epsilon naught epsilon r a by t. Epsilon naught epsilon r a by t. Remember dear students, this is the relative permittivity of crystal. Relative permittivity of piezoelectric crystal. चलो, so force की वजह से charge आया, charge की वजह से capacitance आया. Now capacitance क्या होता है इधर देखो. As a force is dynamic, this charge goes on changing. When the charge goes on changing, now at these terminals, I am going to get certain output voltage or not. Why? Because the charge is dynamically changing. So can I write this is going to generate a voltage according to relation Q is equal to CV. According to relation Q is equal to C. समझ में आ रहा आपको सब लोगों को? Sir, piezoelectric crystal can be used for sound conversion to electricity. Yes. Yes. Shubham, yes. Yes, Shubham, correct. Shubham, correct. This is a microphone. This is a microphone. This microphone can be designed with piezoelectric crystal inside. This microphone can be designed with capacitive technology also. There are capacitive type of microphones. There are piezoelectric type of microphone also. Very good, very good, very good. See, that's what Shubham I am telling. Whenever anybody, whether he is a science student or electronic student, if he wants to do any project, if he wants to do any thesis, if he wants to do any doctorate, he has to come in contact with my subject sensors. he has to come in contact with my subject sensors. चलो, so Q is equal to CV. if I am right here, if I अगर इधर लिख दो क्या होगा, Q is equal to CV, so Q is equal to CP and E naught. So E naught is equal to Q by CP, Q by CP, Q is equal to D into F, Q is equal to D into F, CP is equal to epsilon A by T. So epsilon A by T, epsilon A by T. So if I write here, so E naught is equal to D by epsilon is a constant, F by A is pressure or stress, and T. So now I can write this T this side, and this I am taking as one more parameter called G, and this F by A as it is. Now I am going to get G is equal to E naught by T by F by A. E naught by T means what? Volt per meter, that is nothing but electric field. F by A is nothing but stress. So G is defined as electric field intensity by applied stress. Electric field intensity by applied stress. समझ में आपको सब लोगों के लिए? इलेक्ट्रिक फील्ड इंटेंसिटी बाय अप्लाइड स्ट्रेस, यूनिट्स क्या होगा जल्दी बताइए? इलेक्ट्रिक फील्ड के यूनिट्स क्या होगा? वोल्ट पर मीटर, स्ट्रेस का यूनिट्स क्या होगा? न्यूटन पर मीटर स्क्वायर, देन क्या होगा? वोल्ट मीटर पर न्यूटन होगा, वोल्ट मीटर पर न्यूटन होगा. सो दिस इज आवर G. ये और एक सेंसिटिविटी का फार्मूला है, और एक सेंसिटिविटी का फार्मूला है. ऑल ऑफ आर फॉलोइंग बेटा? सो G is defined as electric field by stress or E naught by T by F by A. ओके ना? सो यूनिट्स होता है वोल्ट मीटर पर न्यूटन, एंड इट इज कॉल्ड एज वन मोर सेंसिटिविटी बेटा, दैट इज वोल्टेज सेंसिटिविटी. वोल्टेज सेंसिटिविटी समझ में आपको? और इफ यू गॉट द क्लैरिटी? Yes sir, very good. Vivek, correct. 100 newtons you are telling. Let us check. Very good, very good, very good. If you are understanding, you can show me thumbs. If you can show me some love symbols. आपका जो कुछ प्यार, जो कुछ comments, जो कुछ constructive comments, because I am serious about the comments. If you give constructive comments, then only it will be useful for everyone. If you have any destructive comments, you can take my personal, but here you cannot comment there. In this public domain, don't comment like that. प्लीज टॉक इन ए कंस्ट्रक्टिव वे. वेरी गुड राहुल जयसवाल, समझ में आपको ना? सो दो पैरामीटर्स डिस्कस किया राहुल, मैंने चार्ज सेंसिटिविटी डिस्कस किया, वोल्टेज सेंसिटिविटी डिस्कस किया, और एक सेंसिटिविटी भी है. एक बार इधर देखिए. नाउ हियर बेटा, इफ यू सी हियर, हमारा बेसिक जो कुछ है, सॉरी प्रीवियस में है ना, सॉरी इधर या, when you are applying the force, this is a surface area, this thickness is going to be changed or not? Yes or not? So here if you take this as our structure, listen carefully, if you take this as our structure, this is our thickness राहुल विश्वनाथ, मैंने फोर्स इधर अप्लाई कर रहा हूं, ओके ना? सो फोर्स पर एरिया, then the thickness is going to be changed. So this is the change in thickness, can I say? Now can I apply Hooke's law? So according to Hooke's law, F by A is equal to Young's modulus into strain. Strain का notation क्या होता है? Delta T by T. Can I call this delta T as some displacement X? Force की वजह से deflection हो गया. So can I call this as X? So what happens now? F by A is equal to Y into X by T. ये X क्या बोलते हैं इसको? X बोलते हैं input displacement due to force. input displacement due to force. So if you write this x f into t by y into a, so this is one more formula. Every formulas are important. Instrumentation बच्चे IN लोगों मैंने बोला आपको, you are going to get around 70 to 80 formulas in the entire subject of sensors and instrumentation. अगर ये 70 to 80 formulas पर आपको conceptual clarity है, एग्जाम में 8 marks और 10 marks आने की 100% chances है. So don't miss those 10 marks. Input displacement. Now if you take this, from this if you take E naught, E naught is equal to G into F by A into T. हम बोलते हैं इसको E naught is equal to GPT. See, these are the formulas. You should have some techniques to remember the formulas, Vishwanath. I used to tell my students techniques. Suppose GT, there is a Grand Trunk Express. Just I want to give these hints also so that you can remember the formulas. Why? Because these are fundamental formula. E naught is equal to GPT. You take this GT as GT Express. मालूम है आपको? GT Express train है Grand Trunk Express. Grand Trunk Express is from Delhi to Chennai. That is a train. Grand Trunk Express. So GT Express में पैसेंजर बैठा है. GT Express में पैसेंजर मिडिल. Okay na? So that is a way to remember. Please provide theory book of sensor. शुभम, ऐसा रिमेंबर करना है, GT एक्सप्रेस में पैसेंजर है. समझ में आपको? GT एक्सप्रेस में पैसेंजर है. GT बोलो तो दिल्ली टू चेन्नई. So like that, some techniques होना है ना भैया. Formulas remember करने के लिए थोड़ा techniques होना है ना. So I used to have so many techniques when I was writing my BTech exams. I used to have so many techniques. Suppose जो कुछ side headings होता है हमारे एग्जाम में, सपोज एक कैसे क्वेश्चन है, एक सब्जेक्ट था थ्योरी सब्जेक्ट, सपोज मेफा बोल के एक सब्जेक्ट, वो सब्जेक्ट में क्या होता थ्योरी. सो वी यूज्ड टू रिमेंबर द साइड हेडिंग्स फर्स्ट लेटर्स. SWOT, S बोलो तो स्ट्रेंथ, वीक W बोलो तो वीक, O बोलो तो अपॉर्चुनिटी, T बोलो तो थ्रेट, SWOT एनालिसिस. लाइक दैट वी शुड हैव सर्टेन शॉर्ट. ये करेक्ट है विश्वनाथ, ऐसे ही प्रिपेयर होना है, क्योंकि इतना सारा फॉर्मूलास है. सेंसर्स में इतना फॉर्मूलास आएगा, एनालॉग में ट्रांजिस्टर, डायोड्स, रेक्टिफायर्स में बहुत सारा फॉर्मूलास आएगा, मेजरमेंट्स में भी बहुत सारा फॉर्मूलास आएगा. सो कितना फॉर्मूलास इन द डे ऑफ एग्जाम यू हैव टू रिमेंबर दीज ऑल फॉर्मूलास. सो व्हाइल रिमेंबरिंग these formulas, always you cannot by heart. So you should have some short tricks. We should have some short tricks. Please try, please all of you type there, GT Express में passenger. Please all of you type there. E is equal to GPT. All of you type there. I'm expecting your comment there. E is equal to GPT. Yes sir, in BTech I done with non-technical subject and many formulas in tech. Very good. Please all of you type there. I'm expecting all of you to type there. E is equal to GPT. All of you please type there. सब लोगों please type there. E is equal to GPT. Why? Because single formula. The single formula will be useful for all problems of Piezo. Very good. GT Express में पैसेंजर है. Very good. E is equal to GPT. Why? Because if you remember this formula, everything will be easy beta. Why? Because he will give you the pressure. He will ask you the voltage. He will give you the voltage sensitivity and he will ask you the voltage. And he will give you the stress and voltage. He will ask you the voltage sensitivity. Or he will ask you charge, he will give you charge sensitivity. He will ask you the E naught. ऐसा भी लिख सकते हैं क्योंकि G is equal to D by epsilon ना. G is equal to D by epsilon previously. चलो. Now, you got E naught here and you got X here. ये दोनों को मिक्स करेंगे. So E naught by X क्या होगा? So E naught is equal to GPT. And X is equal to F by A T by Y. So this F by A means pressure. So this pressure and this pressure gets cancelled. Na? This value gets cancelled. This T gets cancelled. So you are going to get G into Y. Na? You are going to get G into Y. So this G into Y, G is a sensitivity, Y is Young's modulus. So if you see this is one more sensitivity आ रहा है ना, E naught by X. Can anybody tell that E naught by X? Shanad, E naught by X. So what is this E naught by X? E naught by X means output voltage per input displacement. So that means what it is going to happen? Output voltage by input displacement. So that is nothing but displacement sensitivity. और इसका formula है G into Y. So this is called H. क्या बोलते हैं उसको? H. So dear students of instrumentation, electrical and mechanical, so this H is called displacement sensitivity. Okay ना? So तीन formulas, D का formula, G का formula, H का formula. So if you remember these three formulas, Piezoelectric में पक्का आपको 2 मार्क्स और 4 मार्क्स भी आ सकता है. 1, 2, 4. 1, 2, 4. कैसा? एक सिंगल मार्क क्वेश्चन आ सकता है और 2 मार्क्स क्वेश्चन फिल इन द ब्लैंक्स भी आ सकता है, न्यूमेरिकल क्वेश्चन भी भेज सकते हैं. सो लेट अस टेक फाइनल फॉर्मूलास. फर्स्ट D is equal to Q by F, units coulombs per Newton. Next G is equal to electric field by stress, that is E naught by T by F by A. Units होता है voltmeter per Newton. Next H is equal to, बोलिए, E naught by X input, that is G into Y. Units होता है volt per mm और meters भी लिख सकते हैं. All of it clear? So we will call this as charge sensitivity. We'll call this as voltage sensitivity. We call this as displacement sensitivity. Clear all of you? सब लोगों को समझ में आया दोस्तों? Sometimes he may not mention the name of the sensitivity. Sometimes he may give a common name of sensitivity. You have to identify it is what sensitivity. It is charge sensitivity या voltage sensitivity या displacement sensitivity या you have to identify from the units. You have to identify from the. Chalo. Got it? Now we'll go for the question. Try to answer this question. Fast. Some people say 100 newtons. Try to answer this question. I am expecting the answer. Hundred newtons coming, sir. Very good. A quartz crystal Young's modulus is given. A quartz crystal Young's modulus is given. Y is given. Piezoelectric paper has a diameter is given. So diameter is given. Diameter of 10 mm. Okay na? So I will do here. So that place is here. I will do here. Yeah. So what is given? A quartz crystal Young's modulus is given. We'll do one thing. I will go to the screen. So quartz crystal Young's modulus first. Young's modulus is given. Young's modulus is 9 into 10 power 10 Newton per meter square. Please take care of units. Don't make silly mistake. Next, it has a diameter of 10 mm. Yes or not? Diameter of 10 mm. Diameter of 10 mm. उसका मतलब क्या है? The piezoelectric crystal surface area is a circle. The piezoelectric crystal surface area is circle. Then what is the area? Area is equal to pi d square by 4. So please take care of units. mm को meters में convert करना है 3.14. Diameter is 10 mm. That is 10 into 10 to the power of minus 3 meters whole square by 4. Next, it has voltage sensitivity constant 4500. See, all of you listen here. Is it G beta? Is it G? Please answer my question. Is it G? Stuart, is it G? You have done a mistake, I think. Shubham Mathur, is it G? 4500 volt per micrometer. Is it G? No, it is not G. Why? Because units of voltage sensitivity will be, it is not voltage sensitivity. Unit check karo, 4500 volt per micrometer. Yes or not? Try to answer my question. Units of voltage sensitivity kya hai? Voltmeter per Newton. So what is given is H, volt per mm, dear students. So what is given is H. What is given is H. All of you understood? So this is what? This is not voltage sensitivity. Trick post किया है क्योंकि मैंने बोला है एग्जाम में sensitivity is a common phenomena. Sensitivity, you can call charge sensitivity, sometimes you can call sensitivity, sometimes you will call a constant, sometimes you will call a energy constant, sometimes you will call proportional constant, sometimes you will call characteristic constant. In सब cases में आपने units को priority देना है. It is H. Yes, it is H. That's what I'm telling. It is H. Okay, na? He has given H. See, somebody is asking. This is an instrumentation only. Okay, na? Amaya Dalvi. It is an instrumentation course only. Okay. So H is given. H is how much is given? 4500 volt per micrometer. 4500 volt per micrometer. And what he is asking is the voltage output is also given. How much is the voltage output, beta? Voltage output is how much? Voltage output is 127.3 and is asking the force. 127.3. 127.3 volts, right? It is volts only, na? 127.3 volts. Then output force is asking how to do it. If you want to do it, you can use this formula. E naught is equal to G into P into T. G is equal to, not given, he has given H. H is equal to G into Y. H is equal to G into Y. So from this you can write G is equal to H by Y. So G is equal to H by Y. And P is equal to force per area into thickness. Followed? So from this if you write E naught into Y into A by H into T is equal to force. Please solve once again. Please all of you solve once again. Are you going to get 100 newtons? एक बार चेक कर दीजिए. शुभम एक बार चेक कर दीजिए. विश्वनाथ शर्मा चेक कर दीजिए. राहुल जायसवाल चेक कर दीजिए. आंसर कितना आ रहा है? चेक कर दीजिए आंसर कितना आ रहा है जल्दी. देवी इट इज ए इंस्ट्रूमेंटेशन कोर्स ओनली. नमस्ते प्रमित, प्लीज सॉल्व. आंसर कितना आ रहा है? आई एम एक्सपेक्टिंग आंसर. शुभम माथुर एक बार चेक कर दीजिए. 100 न्यूटन्स या E naught, otherwise I will do. So calculation part, please take care of the calculation part. F is equal to E naught into Y area pi d square by 4 and HT. ओके प्लीज सिंप्लीफाई, जल्दी जल्दी सिंप्लीफाई करो, आंसर कितना है एक बार चेक कीजिए. E naught is given 127.3. Next, y Young's modulus is given as 9 into 10 power 10. 9 into 10 power 10. This is pi 3.14. Diameter is 10 mm. 10 into 10 power minus 3 whole square. Displacement sensitivity is given as 4500 microvolts, 10 to the power of minus volts per micrometer. What is given? Just check it. 4500 volts per micrometer. Sorry, that means 10 power 6. 10 power 6 volt per meter. Thickness is, I think the thickness is given or not? Thickness. Yeah, thickness is 2 mm. Thickness is 2 mm. Thickness is 2 mm. 2 into 10 power minus 3 and 4. Please check the answer. What is the answer? 100 newtons. Yes, sir. 100. Okay, perfect. 100 newtons. So you will go for the option A. Sahi hai? Done. Shall we go for the next question? Next question. See here. This question try to answer. Question number 15. Question number 15. Try to answer. I hope question number 15 is visible for all. A piezoelectric type 50 megapascals full scale pressure sensor. Try to answer. A piezoelectric type 50 megapascals full scale pressure sensor with built-in electronics has a sensitivity of 100 millivolts per megapascal. If the sensor is subjected to a static pressure of 10 megapascal, then its output will be dash. Excellent. Rajat Ram says 0 millivolts. Hi Gaurav, I am fine. How are you, sir? I am from Kolkata. Gaurav, I am fine. Very good. 0 millivolts. See, you can think like this, sir. आपने बोला sensitivity बोलो तो how many output by input? So he has given the sensitivity as 100 millivolts per megapascal. 100 millivolts per megapascal. That means for 1 megapascal pressure, you are going to get 100 millivolts. For 1 megapascal, you are going to get 100 millivolts. Then for question asked is 10 megapascal, sir. So 10 megapascals bolo to 10 rupees. That means 1000 millivolts. So answer hoga 1000 millivolts. Right? Is it the way? Is it the way? Very simple question, na? Nidhi Kumari, hi. Vishwanath, 1000 millivolts, sir. 1 rupee 100 chocolates, 10 rupees 1000 chocolates, sir. But remember, beta, in the question he has kept static pressure. What is kept? Static. So if this is a piezoelectric crystal, on this piezoelectric crystal, if you are standing like this even for 1 day also, your output will be 0. Because जो कुछ आपका weight होता है ना, वो weight, that is the input signal for piezo. Just imagine there is a piezoelectric surface. On that piezoelectric surface, I am standing like this. On this piezoelectric surface, I am standing like this. If I stand 24 घंटे, 24 hours तक, if I stand like that also, the output will be 0. No use. Instead of that, if I am skipping on it, अगर मैंने skip कर रहा हूँ, then क्या हो रहा है? It is going to become dynamic. So static inputs, answer is 0. So option D wrong. 1000 millivolts wrong. The correct answer is 0 millivolts. Clear all of you? The correct answer is 0 millivolts. चलेंगे next question को जाएंगे. All of you clear about that? Very good. Static important in question. Very good. Formula booklet, why? See, एक बार Payal, it is too much. Payal, you have to prepare your own running notes. Payal Agarwal, you have to prepare your own running notes. हमने इतना अच्छा आपको content दे रहे, so you can sit at home and you can write your own short notes. You can write your own short notes. You have to write your own short notes. Formula के लिए separate booklet, you have to design your own short notes. So whenever I am delivering the concept, you can prepare your short notes. Subhajit Sarkar, how are you, sir? I'm fine. I'm fine. I'm fine. चलो next question को जाएंगे. We'll go for the next question. Yeah, we'll solve this question next. Yeah, try to answer this question. Question number 18. A dynamometer arm, this is a dynamometer, see this is a two-dimensional picture, you have to imagine a three-dimension state diagram. This is a dynamometer, this is an arm of the dynamometer. This dynamometer arm makes contact with the piezoelectric crystal. So, if you take this as load cell, if you take this as a load cell, this is my arm, this arm is making a input force on it, Satish Gopal Das, Bagunnara sir. Bagunnanu Satish. Satish Bagunnanaya. I am fine. Okay. Now see this, how to answer this question. A dynamometer arm makes contact with the piezoelectric load cell. What do you mean by load cell? Actually, load cell is a sensor. It is a mechanical device. Load cell aisa hota hai. In strain gauge topic, you could have studied. It is what we call column type load cell. What we call this as column type load cell. All have understood? This is a column type load cell. But this load cell is made by piezoelectric material. This load cell is made by piezoelectric material. समझ में आपको? That means what? If you consider this as a load cell, now if you are applying this particular load cell is in red color, na? So imagine this red color is nothing but piezoelectric layer, a piezoelectric layer. Now on this you are applying the force. When you are applying the force, what happens? This is a piezoelectric crystal, na? So a piezoelectric crystal में क्या होगा? आपको voltage आएगा. Yes or not? So try to answer this. A dynamometer arm makes contact with the piezoelectric load cell as shown. The G constant of the piezoelectric crystal is given. So G is given, that is 15 into 10 power minus 3 voltmeter per Newton. 15 into 10 power minus 3 voltmeter per Newton. Anybody is trying the answer, Shubham? Yeah, 15 into 10 power minus 3 voltmeter per Newton. The surface area of the load cell is 4 centimeter square. So this surface area is 4 centimeter square. A is given as 4 centimeter square. Okay na? And torque 20 Newton. This is creating a torque on it. So the torque is created. The torque is given as 20 Newton meter. So how to solve this? That means, listen dear students, there is a torque generated here. If the torque generated, then what happened? This particular arm will make a upward movement and will fall here. And if the torque is increasing, this arm will move further high and fall. If the torque is increasing here, it will move further high and will fall. That means what do you understand? As a torque here is increasing in the dynamometer arm, if the torque here is increasing, the force applied by this arm on this load cell is increasing or not. So this is our dynamometric section. This is the length of the arm. And this is a force. Suppose if torque is less, this arm will go up to certain height and will fall down. If the torque is more, then what happens? It will go to further height and will fall down. And if the torque is still increasing, it will go to more height and will fall down. So when it is falling like that, it is applying a lot of force na. That means if the torque is increasing, force is increasing, I think all of you know torque is equal to force into length na. Torque is defined as force acting along the normal length or not. So from this we can find out the force na. Torque is already given. What is the torque? 20 Newton meter. So if you substitute torque 20 Newton meter here, force is unknown and the length of the arm is also given. What is the length of the arm? The length of the arm is 0.5 meters na. So this is a L. So if you substitute here 0.5 meters, you are going to get force na. So please find out the force. Please find out the force now. How much force? I am expecting the answer from you. Torque is equal to force into length beta. Torque is already given. So force acting on this load cell we have to find. B will be the answer. Very good. I am asking the force. Shubham, I am taking only crash course. In crash course, I am covering the PYQs of gate questions. ये 30 hours का session only है. ये 30 hours का session में only we are taking some model questions. I am not covering the entire subject here. I am covering only the questions and concepts. 40 newtons. Very good. Very good. Rahul Jaiswal, force is equal to 40 newtons. So the force acting here is 40 newtons. Force acting is 40 newtons. Then you can find out the E naught. So what is the output voltage? That output you can find out. E naught is equal to GPT ना. समझ में आपको? आपका फॉर्मूला यूजफुल होगा अभी? डियर स्टूडेंट्स, आपका फॉर्मूला यूजफुल होगा ना? सो आपका फॉर्मूला यूजफुल होगा. क्या है फॉर्मूला? क्या है फॉर्मूला? जीटी एक्सप्रेस में पैसेंजर है. फॉर्मूला यूजफुल हो गया ना डियर स्टूडेंट्स? फॉर्मूला यूजफुल हो गया ना? निधि कुमारी, शुभम माथुर, राहुल जायसवाल, सुष्मिता, वो फॉर्मूला यूज हो गया ना? जीटी एक्सप्रेस में पैसेंजर है. सो मुझे ई नॉट चाहिए एंड आई थिंक ही हैज गिवन जी. जी इज गिवन एज 15 into 10 power minus 3. 15 into 10 power minus 3 volt meter per Newton. And pressure is nothing but force per area. Force per area into thickness. Thickness is given as how much here? Yeah, thickness is 1 mm here. Thickness is 1 mm here. So you substitute all that information. So 15 into 10 power minus 3. Force is some 40 newtons. Area pi d square 3.14. Sorry, area is already given, right? Area is already given. Area is already given. Okay. So 4 centimeter square. 4 into 10 power minus 1 centimeter is equal to 10 power minus 2. 10 power minus 4. Area given 1 mm. I think this is wrong. शायद we are getting some wrong answer, right? एक second. Please check. I think question में थोड़ा mistake है. I think this is 0.04. I think this is 0.05. Shubham, correct? Otherwise your answers won't match. It should be 0.05. Check it. 0.05. Shubham, you got the answer, but G value is not correct. I think if G value is 15, you won't get the answer as 5 volts, right? Ten power minus 3, 10 power minus 3, 10 power minus 6, 10 power minus 5. ऊपर गया. You'll get something. Something mistake. 0.05 things here. इसे 1.5 आ रहा. 1.5 नहीं है ना ऑप्शन. Please make a correction here. Please make correction. It is 0.05 I think. 0.05 एक बार चेक कीजिए. I think this is a mistake. Printing mistake. 0.05 चेक करो. G वैल्यू एक बार चेक कीजिए 0.05. सपोज इफ आई टेक 0.05, if I take 0.05, then you will get 4 खत्म, 10 power minus 3, 10 power minus 3, 10 power minus 6, 10 power minus 6, 10 power minus 5 ऊपर गया तो so I think it is 0.5. Yeah, you please take it as 0.5. G value, please make a correction. G value, please make a correction. G value, please make a correction. 0.5 into 10 power minus 3. Okay na? There is a mistake, printing mistake. Yeah, please take G value 6 आ रहा है सर, 6 नहीं है. Please take G value. Please take G value. Please take G value 0.5. There is a printing mistake. Please take G value. You can verify in the gate paper. There is a small mistake. 0.5 ले. If you take 0.5 कितना आ रहा है? If you take 0.5 सही आ रहा है? If you take 0.5, take this as 0.5. 0.5 अभी चेक कीजिए. 10 power minus 6, 10 power minus 5 ऊपर गया, 10 power minus 1, somewhere we have done a mistake. Thickness is 1 mm. Five volt should be the answer. If you take 5, I think this G value एक बार चेक करना है. एक बार चेक करना है. I think in unit some mistake, otherwise correct. Yeah, sir, G is equal to 0.05. Okay, let us take 0.05. Suppose if you take 0.05, you're getting, you're not getting, right? Force 40 newtons, area pi d square by 4 centimeter square, 1 mm thickness, 1 mm thickness. No, somewhere there is a mistake in the units. Okay, let us verify that. Let us cover that next. Let us re-verify this particular thing. Okay, let us re-verify this value. I think this value is, I think we have done a small mistake. Let us check this value. Either length or thickness. एक second, let me check. I have a book here itself, I will check. Yeah, sorry, it is 50. It's not 15, it is 50. Please make a correction. Dear students, please make a correction. It is G value is wrong. G value is wrong. Please take from the book I have seen. It is 50. 50 into 10 power minus 3 volt meter per Newton. अभी चेक कर दीजिए, अभी आएगा आंसर. ओके ना? No. Yeah, please check. I have tested from the textbook, from the booklet. 50 into 10 power minus 3 volt meter per Newton. Now check कर दीजिए, आपको आंसर आएगा. सुष्मिता, शुभम, प्रमोद. Now you check it. You will get the answer. So E naught is equal to GPT. E naught is equal to G into F by A into T. So G is equal to 50 into 10 power minus 3. Small mistake in that question. It is not 15, it is 50. So force is equal to 40 newtons aya. Surface area 4 centimeter square, 4 into 10 power minus 4 aya. Thickness is equal to 1 mm, that is 10 to the power of minus 3 aya. 10 to the power of minus 3 aya. So 4 gets cancelled. So 10 power minus 3, 10 power minus 3, 10 power minus 6, 10 power minus 4 gets cancelled. 10 power minus 5, 10 power minus 4, 10 power minus 1. I think you will get 5 volts now. Option B. सही है? विश्वनाथ सही है? सुष्मिता clear? Rahul Jaiswal, very good. चलो. Next question. Shall we go for the next question? All of you show me the thumbs. I think clarity आया. थोड़ा सा small correction है question में. This is the G value, not 15. You please take 50. Please show me the thumbs. We'll go for the next question. We'll go for the next question. चलो. Yeah. Yeah, try to answer this question. Question number 22. A piezoelectric type accelerometer. A piezoelectric type accelerometer has a sensitivity of 100 millivolts per gravity. The transducer is subjected to a constant acceleration of phi z. Then the steady state output of the transducer will be dash. So this was also a gate question. Answer please. Answer. Simple. A piezoelectric type accelerometer has a sensitivity of 100 millivolts per gravity and subjected to phi z. So simple na. Again same 100 millivolts per G. That means for 1 G 100 millivolts and it is applied for how much? Phi z. Phi g means 500 millivolts. So 500 millivolts means 10 to the power minus 3, 10 square and 0.5. So answer is 0.5 volts na? Answer is it 0.5 volts? Very good Shubham. Shubham bol rahe 0.5. How many of you say 0.5? So 0.5 simple na? Any other answers? Sushmita, your answer. Yeah, it is. But have you observed Shubham? Constant. Constant. Vishwanath, have you observed here constant? Constant. Constant means static. Then what is the answer? 0 na? Rahul Jaiswal, Shubham? 0. So the correct answer will be 0 volts. देखो simple question. Question में constant है, question में constant है, क्वेश्चन में स्टैटिक है और क्वेश्चन में डीसी है. आंसर विल बी 0 volts. क्लियर ऑल ऑफ यू? क्वेश्चन में स्टैटिक है, क्वेश्चन में स्टैटिक है, क्वेश्चन में डीसी है. आंसर विल बी 0. शुभम मिस हो गया, नेगेटिव मार्किंग आ गया. राहुल जायसवाल, शुभम. Rahul Jaiswal has given the correct answer. Vishwanath, you lost the mark. Negative marking. All of you understood these points? Chalo. Now we'll go for somewhat typical questions. See this question. What is this question? Try to answer this question. Yeah. Try to answer this 19th question. All of you go through the 19th question. Yeah, Shubham, Nidhi Kumari, try to see this 19th question, very different question, very different question. Question is available in the booklet or you can see here. That soft copy is available there. How many of you understood the question first of all? A barium titanate piezoelectric crystal with D33. So this is the charge sensitivity. See what is given? He has given D33. How many of you understood this word D33? D33. How many of you understood D33? D33 is 150 picocoulombs per Newton. That means if you take the cube structure generally, so this is having 3 axes, am I right? This is having x axis, z axis, y axis. Okay na? So this is, let us take 1, let us take this as 2, let us take this as 3. Directions. The directions matter, yes or not? Why? Because in which particular direction you are applying the force, accordingly that particular molecules will be disturbed. Na? Hexagonal structure, silicon oxygen 1 pair, but here 2 pairs, na? Yes or not? That's why the direction matters. The direction matters. So he has applied the force in this third axis. That's why I will take this as 1 axis, this as 2 axis, this is a 3 axis. Okay na? So these are 3 axis, this is a 1 axis, this is a 2 axis. All of you understood? All of you understood this point? Shubham, yeah. So this is a D33 is applied like that. Next. A barium titanate piezoelectric crystal with D33. See, capacitance of the crystal is given 25 picofarads. So capacitance of the crystal is given, capacitance of the piezo is given 25 picofarads. 25 picofarads. And resistance of the crystal is given 10 to the power of 10 ohms. Resistance of the piezoelectric crystal is given 10 to the power of 10 ohms. 10 to the power of 10 ohms. Is used to measure the amplitude of step force. Amplitude of step force. Step force means what? One step force like this. One step force. The voltage output is measured using a digital voltmeter with input impedance of 10 to the power of 13 ohms. So this is connected to a digital voltmeter. This is a voltmeter. This voltmeter is having DVM is having the meter resistance as 10 to the power of 13 ohms. Dear students, actually speaking, step means what? A instantaneous force. That's it. So what happens actually? Suppose imagine this is a piezoelectric crystal surface. This is a piezoelectric crystal surface. Right now, at t is equal to 0, nothing is there. Just at t is equal to 0 place, a force of 2 newtons is hitting like this. Actually speaking, output is 0, but at t is equal to 0 plus some 2 newtons of force is hitted, then instantaneously some voltage is available or not, Shubham? Instantaneously some voltage is available or not? So that voltage I want to grab. So this is purely dependent on the absorbing capacity of DVM. Absorbing capacity of DVM means it is related to time constant of DVM, digital voltmeter. That means it is just like whenever you apply a force, that means if you take the graph with respect to time and with respect to the voltage developed. Now at t is equal to 0 seconds, you have applied a force. So Vishwanath following, Sushmita, Nidhi Agarwal, all of you following, Rahul Jaiswal, Shubham, Nidhi Kumari, Sushmita, other active students, other all active students, all of you following or not? Yeah, it is applying a instantaneous force. When you apply at t is equal to 0 a force of 2 newtons, then there is a suddenly some voltage will be developed or not? Some voltage will be instantaneously some voltage will be developed. After that what happens when you remove this step force na? So step force is just with respect to 2 newtons. How much? 2 newtons. A step signal of 2 newtons. 2 newtons of force is applied, that's it. Okay, so instantaneously some voltage will be developed, a maximum voltage will be developed, but after t is equal to 0, what happens? The voltage developed, will it stay there or will be decay to 0? Sushmita, will it stay there or will it be decay to 0? Why? Because there is no force na. After t is equal to 0, there is no force. Sir, it will be impulse type voltage as impulse applied. Yes. At t is equal to 0, you are getting certain force. Step, okay, 2 newtons of force. Then what happens? Slowly it will be decaying to 0. Shubham, correct? Slowly it will be decaying to 0. Shubham, एक बार क्वेश्चन देखो, क्वेश्चन में क्या दिया है? He has given a step force of 2 newtons. क्वेश्चन में क्या दिया है? He has given a step force of 2 newtons. A step force of 2 newtons is applied in direction 3. So it is clear that whatever the force is applying, that force is applied in the direction 3 also. So direction is related to this particular force, this particular charge sensitivity only given na. Am I right, Shubham? Yes. दीपक कुमार, ये इलेक्ट्रिकल के लिए अगर आपने, सुष्मिता, व्हाट यू आर सेइंग 0, आई डोंट अंडरस्टैंड. Yeah, it will be type impulse voltage, but what happens? The voltage developed. See, you are not understanding. That current whatever is developed, over a period of time it decays to 0. दीपक कुमार, ये इलेक्ट्रिकल के लिए गेट में नहीं है, गेट इंस्ट्रूमेंटेशन पेपर लिखा तो होगा. If you are writing gate instrumentation paper, it will be useful. So see, it is just like, just imagine there is a piezoelectric crystal. Shubham, there is a piezoelectric crystal. I am taking a step on it and going like this. समझ में आपको? There is a piezoelectric crystal. I am keeping my leg 2 newtons and I am going. Then what happens? Instantaneously some voltage develop होगा. Shubham, do you understand? I am keeping a step of 2 newtons and going. Then instantaneously some voltage will be developed. Over a period of time, then what happens? That voltage decays to 0 or not? Excellent, excellent. This is the beauty of this question. Actually speaking, Shubham, can you measure this voltage? Why? Because as per the piezoelectric concept, piezo is not suitable for static inputs. Suppose if you are doing skipping on it, then you can measure it. Just you are applying a force for a moment and you are removing, then you cannot get any output voltage actually. But what he has done, he has connected a digital voltmeter. Very excellent question, na Shubham. He is planning, as per your previous analysis, piezoelectric crystal is not suitable for static inputs. Okay, bye, understood. But this is exceptional. I want to measure that type of instantaneous force. A instantaneous force. Who is this? Tamjeed Shah. Who is this Tamjeed? Bye bol rahe. Okay. So when you apply certain instantaneous force, then instantaneously some voltage will do. I want to measure that. वो voltage measurement करने के लिए मुझे a DVM का characteristics are important. That means before decaying to 0, if you can capture something. Suppose, let us take this at a particular time. Suppose at a particular time you can get something. Definitely whatever you are going to get will be lesser or not. Why? Because at t is equal to 0, catching is not possible. T is equal to 0, after only you have to catch it. That is a very conceptual question. देखो. All other capacitance and resistance may be neglected. A step force of 2 newtons is applied from the direction 3 on the crystal. The last line is most important. The time in milliseconds within which the voltmeter should sample the crystal output voltage so that the drop from the peak value is no more than 0.12 volts. How many of you understand this last line? Once again I am asking. The time in milliseconds within which the voltmeter should sample the crystal output voltage so that the drop from the peak value is no more than 0.12 volts. Once again try to understand. How many of you understand this line? Anybody? Shushmita, Shubham Mathur, Deepak Kumar. How many of you understood this line? How many of you understood this line? The time in milliseconds within which the voltmeter should sample the crystal output voltage so that drop from the peak value is no more than 0.1. क्या English language है? ये English language है. शुभम? Sir, confusion na? हाँ. See the clarity, the quality of English. What is asking? The time in milliseconds within which the voltmeter should sample. That means question तो clarity होना, question क्या पूछ रहा है? Is asking the time. Is asking the time. At what time I should sample some voltage so that I will get something. Shubham, I will get something. That something will be definitely lesser than the actual or not. At a particular time, suppose if you check this particular time, what you are getting here is the voltage or not, voltage that you are getting at a particular time or not, voltage you are getting at a particular time or not, voltage available across the crystal or not. So definitely this is the V max, this is the Vc of t. So who will be more? V max is the highest value that can be taken as true value. V max is a true value, and what you are getting at a particular time, that is Vc of t. Vc of t, voltage available at the crystal at a particular time, that is a measurement value. समझ में आपको सब लोगों को? शुभम, is it clarity? हाँ, find the time, voltage. Very good, very good, very good. Means sir, output is given due to step. Yes, yes sir, understood. Pratham, who is this? Prathamesh, Prathamesh. Shubham, now clarity आया, clarity आया. I will tell you one thing. शुभम, आपकी लैंग्वेज में बताता हूँ. I will give one example. राहुल जायसवाल, I will give one example. हमारा सुष्मिता का घर में एक फंक्शन हो रहा है. सुष्मिता का घर में एक फंक्शन हो रहा है. सो मेनू क्या है? सब आइटम्स है, सब आइटम्स है. रोटी है, पालक पनीर है, दाल है, बिरयानी है, स्वीट्स 4-5 स्वीट्स है. एंड में एक आइसक्रीम भी है. ऑल ऑफ आर लिसनिंग? एंड में एक आइसक्रीम भी है. A function starts at t is equal to 12 o'clock. Afternoon 12 o'clock को function starts. Okay ना? शुभम, function starts at 12 o'clock. अगर आपने 12 o'clock को directly, if you are in the function hall, you will get all the items in your plate. आपको सब मिलेगा. आपको पनीर मिलेगा, रोटी मिलेगा, खाना मिलेगा, राइस मिलेगा, स्वीट्स 16 का 14 का स्वीट्स, जो स्वीट्स मिलेगा, आइसक्रीम भी मिलेगा. अगर आपने स्टार्ट हो रहा है, लेकिन आप उसका घर में नहीं है, आप यू आर फ्रॉम ए फार डिस्टेंस, यू हैव टू स्टार्ट फ्रॉम देयर, यू हैव टू स्टार्ट फ्रॉम देयर, एंड दैट नाउ हाउ एट व्हाट टाइम यू विल रीच, दैट इज डिपेंडेंट ऑन युवर बाइक. एट व्हाट टाइम यू आर गोइंग टू रीच, అంటే ఎట్ వాట్ టైమ్ యూ ఆర్ గోయింగ్ టు రీచ్, by because by that more rush is there. as a time is crossing क्या होता है? 12 o'clock को फंक्शन स्टार्ट हो गया, 12:30 को पनीर खत्म, 12:30 को पनीर खत्म, 12:45 को आइसक्रीम्स खत्म, 12:45 को आइसक्रीम्स खत्म, 1:30 को बिरयानी खत्म. समझ में आपको? क्योंकि लोग हैं ना उधर. सो क्योंकि what always remember देर दोस्तों, what is available right now is always exponentially decreasing component of what was available. My sentence ध्यान से समझ में आना. Please take care of my statements. What is available in your lifetime right now is always exponentially decayed component of what was available. शुभम माथुरी, शुभम माथुर, आपका एज कितना है अभी? शुभम माथुर, आपका एज कितना है? शुभम माथुर, आपका एज कितना है? आई एम एक्सपेक्टिंग आंसर. नो प्रॉब्लम, you can tell your age. हाँ, you can tell your age. Let us take सुष्मिता का एज. Let us take सुष्मिता का एज. राइट सर. शुभम, आपका एज बताइए जल्दी 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 जल्दी. हाँ, 24, right, 24. Let us take the lifetime of Shubham is 100 years. Okay na? Let us take the lifetime of Shubham is 100 years. Lekin right now, what is the lifetime available for you, Shubham? If your lifetime is 100 years, right now, what is the lifetime available in your hands? 100 minus 24 na? 100 minus 24 or not? If your total life is 100 years, आपका लाइफ ऑलरेडी 24 ईयर्स हो चुका है, जिंदगी में 100 साल 100 ईयर्स में ऑलरेडी 24 साल खत्म हो गया है, आपके हाथ में कितना अभी? ऑलमोस्ट 76 ईयर्स ओनली इन योर हैंड. डू यू अंडरस्टैंड माय पॉइंट? दिस इज व्हाट द ग्रेटेस्ट लॉ व्हिच इज related to our instrumentation. What is available is always, what is available life for you always, comparatively at when you birth, at t is equal to 0, at t is equal to 0, your birth life is 100 years available, but here you have already crossed 24 years, now remaining is only 76 years is available. So what is available at t is always lesser than what was available at t is equal to 0. Am I right? Am I right, dear students? Am I right, dear students? So if you go to the function to the Sushmita home at t is equal to 0, आपको प्लेट में सब कुछ मिलेगा, पनीर मिलेगा, राइस मिलेगा, बिरयानी मिलेगा, सब कुछ मिलेगा. अगर आपने डिले हो गया, by the time you go here, then क्या मिलेगा आपको? एक प्लेट में एक लास्ट रोटी है, लास्ट रोटी मिलेगा. Yes or no? Yes or no? So now what you are going to get? Definitely, what you are going to get is always measurement value. What was actual, that was a true value. Definitely what you are going to measure, what you are going to get minus what was actual. If you check this, this is nothing but error or not. This is always going to be negative or not. Can I call this as a drop or not? Rahul Jaiswal, can I call this as a drop or not? So in our, that means what? Now what you are going to get, it depends upon at what time you are going to reach Sushmita's home. At what time you are going to reach Sushmita's home, that depends upon the time constant of your bike. आपका बाइक का कंडीशन कैसा है? What is the time taken by your motorbike to reach that home? That will give you the thing what you are going to get. This is a beautiful point. That means at what should be the sampling time of this particular digital voltmeter, so that I will get something, that something will be lesser than the actual. That's what he has given in the question. Dekho. The time in milliseconds within which the voltmeter should sample the crystal output voltage. समझ में आपको? Within which, and before that only I want to achieve, within which the voltmeter should sample the crystal output voltage, so that the drop, this is important, drop means what? Error. Error means negative. Drop, so that the drop from the peak value, drop from the peak value, drop from the peak value, drop from the peak value is no more than 0.12 volts. All of you understood this point, dear students? Measurement value minus true value must be how much? Minus 0.12, minus 0.12 volts. All of you understood this or not? This is the beauty. How many of you understood, Shubham? Quality English. Quality English. I asked a professor, sir, why you have kept the type of English language active voice, passive voice? The time in milliseconds within which the voltmeter should sample the crystal output voltage, so that the drop from the peak value is no more than. So directly you can ask, na, what should be the sampling time of voltmeter to achieve a voltage of this much? I asked that professor, one of my friend professor was asked, he said, this is what I call quality. Okay na? So if you want to get a qualitative question ऐसा होता है, then I asked, sir, why you will test all type of quality on instrumentation students? There are EC students are there, EEE students are there, CSIT students are there. अरे दुनिया में सब लोगों के पास क्वालिटी चेक करो. अरे हमारा इंस्ट्रूमेंटेशन को बुक्स भी अवेलेबल नहीं है, अच्छा सा कॉलेज भी अवेलेबल नहीं है, फैकल्टीज भी अवेलेबल नहीं है. आप हमारे ऊपर ऐसा क्यों इंग्लिश प्रोजेक्ट कर रहे हैं? हमारे ऊपर क्यों ऐसे इंग्लिश प्रोजेक्ट कर रहे हैं? द टाइम इन मिली सेकेंड्स विद इन विच द वोल्टमीटर शुड सैंपल द क्रिस्टल आउटपुट वोल्टेज. Directly you can ask, what should be the time of sampling so that the available voltage at the crystal is so and so. Chalo, first of all, you understand maza aaya Rahul Jaiswal. If you see this particular graph, now what is a Vmax? First, Vmax is nothing but for a particular force of 2 newtons, what is the output voltage? Can I calculate that or not? For a force of 2 newtons, how much is the output voltage that I can calculate or not? By using our basic formula, Q is equal to CV, Q is equal to Cp into E naught, E naught is equal to Q by Cp, Q is equal to D into F, Cp is already given beta. Now if you check this question, is already given the D value. The D value is 150 picocoulombs per Newton. So you can substitute here 150 pico 10 to the power of minus 12 coulombs per Newton. Force is step signal 2 newtons. Capacitance is और एक capacitance कितना दिया भैया? Capacitance of the crystal 25 picofarads. 25 picofarads. You can take 25 picofarads, 25 into 10 power minus 12 farads. So Newton cancel. 10 power minus 12, 10 power minus 2 cancel. 25, this E naught will be 6. 6 into 2, 12. 12 coulomb per farad. Coulomb per farad means volts na. That is nothing but Vmax na beta. That is nothing but Vmax. All of you understood this step? Maza aaya Shubham? Yes. Maza aaya? So we got the 12 volts or not, dear students? All of you are following? Itna acha conceptual questions. That's why I told you, Shubham and other students, Rahul Jaiswal, आपको quality questions पढ़ेगा. Instrumentation का paper में बहुत सारा quality questions आएगा. So E naught is equal to 12 volts Vmax or not? So come back to this. किधर गया रे? हाँ, एक second. So now the picture, can I write this as 12 volts? 12 volts. Sushmita, Shubham, Rahul Jaiswal, Sushmita, are you there? So आपका घर में 12 o'clock को 12 items पका हो चुका है. पनीर है, 12 o'clock आने वाला है. अभी 11:40 हो रहा है. Exactly 11:40 हो रहा है. Exactly at 12 o'clock हमारा सुष्मिता घर में 12 items होगा. पनीर होगा, राइस होगा, बिरयानी होगा, 4-5 स्वीट होगा, एंडिंग में आइसक्रीम भी होगा. बट क्या किया हमने? थोड़ा सा डिले किया. So what I got is this. So now can I take Vc of t minus Vmax. Vmax is 12 volts is equal to minus 0.12. If you send this plus here, now I am going to get Vc of t is equal to minus 0.12 plus 12 or not. That will become 11.88 volts na. So what you are getting is 11.88 volts na. Am I right? 11.8 correct hai na? 11.88 plus 0.12. Sahi hai 11.88? Yes, good morning. So 11.88. So here, sorry. So what you are getting here is 11.88. How many of you understanding? So what you are getting here is 11.88. सही है आपको 11.88 volts. Clear all of you? 11.88 volts. So this is what you got. आपका प्लेट में क्या मिला आपको? सब कुछ मिला, पनीर खत्म. 12 आइटम्स में 1 आइटम खत्म हो गया. ओके ना? बहुत डिले किया शुभम सागर. आपका बाइक बहुत छोटा है, बहुत तेज नहीं है, आपका बाइक में पेट्रोल नहीं है. सो आराम से जा रहा है. आपको क्या मिलेगा? कुछ नहीं मिलेगा. जो कुछ एंडिंग में प्लेट्स होगा ना, एम्प्टी प्लेट्स, वो क्लीन करने के लिए बोला. सो आपका सुष्मिता का फ्रेंड ना अब बहुत सही टाइम पे आया रे. राहुल जायसवाल बहुत सही टाइम पर आया. ऑल द प्लेट्स आर एम्प्टी, प्लीज वॉश द डिशेस. ऐसा ही बोलेगा. यस सर नॉट. व्हाई? बिकॉज यू आर ऑलमोस्ट एट द एंड. That depends, मेरा क्वेश्चन समझ में आया, that depends upon your bike capacity, that depends upon your DVM capacity, digital voltmeter capacity. अगर ये digital voltmeter is having good sampling rate, digital voltmeter is having good sampling rate, वो quick में quick सी very तेज से आपको voltage catch किया, then by using that voltage आपको you can get something. समझ में आपको? Where 10 milliseconds answer आएगा? No, no Shubham. Now what is my question here is, he is asking time. If you see this particular diagram, dear students, if you see this particular diagram, if you take analog concept, Rahul, I will take analog concept. If you take analog concept, it is just like capacitor discharging or not? It is just like capacitor discharging, na? So what is the formula for capacitor discharging? What is the formula for capacitor discharging? Please tell me. If you see, this curve is similar to discharging curve of a capacitor. So if the capacitor is discharging its voltage, then what is the voltage available across the capacitor? Maza aaya? Very good. So what is the voltage available across the capacitor? I think all of you know. Voltage available across a capacitor at a particular time, whether it is a charging mode or a discharging mode, Vc of t, just a second, yeah, V max is 12, yeah, Vc of t is equal to V final plus V initial minus V final into e power minus t by 2. How many of you clear about this analog formula? How many of you know this analog formula? Voltage across a decreasing component is nothing but, very good, V max into e power minus t. Very good, show. Correct. V max into e power minus t by 2. Definitely, na? So V final, if you take 0, V initial is nothing but V max, V final is equal to 0, e power minus t by 2. सही है? Rahul Jaiswal, directly you can remember, available is equal to initial into e power minus t by 2. That's what I was talking. दुनिया का सबसे अच्छा रियल टाइम लाइफ के लिए अप्लाई कर सकते हैं ये फार्मूला, लाइफ के लिए अप्लाई कर सकते हैं ये फार्मूला. जो कुछ आपके हाथ में होगा, दैट इज ऑलवेज लेसर देन व्हाट योर पेरेंट्स वर हैविंग. जो कुछ आपका हाथ में होगा, आपका अवेलेबिलिटी होगा ये नेचर में, दैट इज कंपेरेटिवली योर ग्रैंड पेरेंट्स इट विल बी लेस ओनली. क्योंकि हमारा ग्रैंड पेरेंट्स के जमाने में पोल्यूशन लेस था, नाउ द पोल्यूशन इज मोर. हमारा ग्रैंड पेरेंट्स के जमाने में फूड एंड एवरीथिंग वाज क्वालिटी था, अभी द क्वालिटी ऑफ द फूड ओवर अ डेकेड exponentially decreased. The quality of breath, quality air exponentially decreased. The quality of the lifetime exponentially decreasing. Food quality, ऐसा समझ में आपको? Vc of t, now you can do V max is 12 volts. Vc of t you can substitute. Dear students, listen. Vc of t is equal to 11.88. Vc of t is equal to 11.88. V max is 12. T you have to find out. Tau is already given. See this question. C is given, resistance is given, and this impedance is also given. So what is the data given? So we can find out the crystals. See here. So if you see this is a crystal. क्रिस्टल का इंटरनल रेसिस्टेंस है, पैरेलल में क्या है, डीवीएम है. सो डीवीएम का एक रेसिस्टर है, सो दिस अ मीटर रेसिस्टेंस, सो दिस अ क्रिस्टल रेसिस्टेंस, एंड क्रिस्टल का कैपेसिटर भी है, क्रिस्टल का कैपेसिटर भी है. सो कैपेसिटेंस ऑफ द क्रिस्टल. सो टाइम कांस्टेंट क्या होगा, टाइम कांस्टेंट क्या होगा, टोटल आर इक्वलेंट इंटू सी इक्वलेंट होगा. Time constant RC na. So what is the R equivalent? That is nothing but capacitance, resistance of the crystal in parallel with resistance of the meter, and C equivalent क्या होगा, capacitance of the crystal. So if you see resistance of the crystal, he has given meter resistance is given 10 to the power of 13, this is 10 to the power of 10, yes or no? So this is 10 to the power of 10 ohms and this is 10 to the power of 13 ohms, okay na? So now both are parallel. In parallel, highest resistance can be eliminated, approximately it will become 10 to the power of 10 ohms. And capacitance of the crystal is given, capacitance of the crystal 25 picofarads, so that also given, so 25 picofarads, 25 into 10 power of minus 12, then how much you are going to get beta? How much you are going to get? 25 into कितना आ रहा है 25, so 0.25 seconds आ रहा है ना, yes or no? 0.25 seconds आया, yes sir, point बिल्कुल 0.25 seconds आया. So 11.88 is equal to 12 into e power minus t, tau is 0.25, so please simplify. 11.88 by 12 is equal to e power minus t by 0.25. So if you apply the natural logarithm, 11.88 by 12 is equal to minus t by 0.25. Am I right? So this will become ln 12 by 11.88 is equal to t by 0.25. So t will be equal to 0.25 into ln 12 by 11.88. Please tell me the answer. This is ln, natural logarithm. Please tell me the answer. 2.5. Units बताइए, units बताइए शुभम, units. The time in milliseconds, right? The time in milliseconds. So answer is 2.5. Perfect. 2.5 milliseconds. Very good. The correct answer is 2.5. मजा आया? Dear students, मजा आया? राहुल, क्लैरिटी है ना? सब लोगों को समझ में आपको? समझ में आपको 2.5 milliseconds? So the correct answer is 2.5 milli. Understood all of you? What a clarity, right? Rahul Jaiswal, you are from NTPC Ramagundam, right? Rahul Jaiswal, you are from NTPC Ramagundam. You are working professional. I think you are working professional, Rahul Jaiswal. You are working for NTPC, right? National Thermal Power Corporation, nearby Karimnagar. Yeah. Vijay Lakshmi Misra, very good. Vinod Kumar. You are working, Rahul? Very good. चलिए. So clarity है. चलो next question को जाएंगे. Last question. So try to answer this simple question. For signal conditioning of piezoelectric type transducer, we require dash. Try to answer this one more question. IN student, okay. I am from Calcutta. Okay, very good. Now try to answer this question. For signal conditioning of piezoelectric transducer, we require dash. we require dash a charge amplifier, a differential amplifier, instrumentation amplifier, and transconductance amplifier. What's the answer? Very simple questions na Manish? Yeah, ऐसा simple questions आना है. Why? Because piezoelectric type uses charge amplifier. Charge amplifier. This is somewhat important signal conditioning. I want to give some ideas. See here. For strain gauge signal conditioning, for strain gauge, so this is a transducer and this is the signal conditioning circuitry. Signal conditioning circuit. SCC means signal conditioning circuit. Signal conditioning circuit. For strain gauge, the suitable signal conditioning is Wheatstone bridge. Wheatstone bridge. Okay na? Next. For Piezoelectric transducer, the suitable is charge amplifier. Next. For thermocouple, the choosable signal conditioning is chopper amplifier. Next, for pH electrode, pH transducer, the suitable is FET amplifier. Okay, na? So these all are some standards you have to remember. Clear all of you? Some standards. Okay, so these are according to their input impedance. What are the, see how this matters means according to their input impedance, offset current, okay na, output impedance, gain factor, S by N ratio, slew rate, okay na. So all these characteristics matter. All these characteristics matter for this particular thing. According to these characteristics, they will choose this. All of you clear about this? Yes or not? So please remember, these are suitable signal conditioning circuits. Okay dear students, मजा आया सब लोगों के लिए? So Piezo का बहुत अच्छा शानदार questions पढ़ा है हमने. We have taken some qualitative questions आज. Okay. So tomorrow there will be, I'm closing this session. So now you can practice with this knowledge, you can practice the strain gauge. Yes, sir, for LVDT is there a specific SCC? Yes. So, for LVDT, see for LVDT, we have phase sensitive demodulator. Plus low pass filter. Okay na? So that is also one important point. Somebody asked, Manish asked, I think. Manish, you asked. So these are the important things. Like this, signal conditioning is pura analog hai. Signal conditioning is completely analog. Okay na? And we can choose for capacitive transducers. for capacitive transducers CT, we can choose AC bridges. AC bridges. Done like this. AC bridges. For strain gauge, we can use DC Wheatstone bridge enough. Okay, na? AC bridges for capacitive transducers. Signal conditioning is also important. Okay, na Gaurav Kaur? Chalo. Enough for today. I am closing the session now. Okay. So with this, you can practice the remaining जो कुछ मैंने पूरा पढ़ाया almost capacitive. In the next class, we'll start some important thing like temperature chapter. Temperature topic start करेंगे. Okay ना? Temperature topic start करेंगे. So next class will be not tomorrow. So next class, I think today is Monday, that is 12th. So tomorrow no 12th, today is Monday. So next class will be Wednesday. So next class will be Wednesday, 14th October. So tomorrow no class. Okay. Next class will be 14th. Maximum time will be 7 PM to 9 PM. Okay. So बढ़िया. आप सब लोगों को inform कीजिए. कल no class. So next class I am going to discuss other topics. I hope all of you understood. So I am closing the session. Tata, bye bye to everyone. Love you all. All of you can please show me some thumb symbol. Yeah. Thank you. Yeah, 7 PM only. Shubham, 7 PM only. आज थोड़ा actually today evening I have to start somewhere. That's why I have taken the morning session. From next class onwards 7 PM only. Shubham Mathur, Riya Tiwari and Rahul Jaiswal, Manish, please share these links to your friend circle. So share, like and forward to all your friend circle of IN team, instrumentation, triple E and biomedical. Okay na? Why? Because it is a crash course na? Crash course and free content दे रहे हम. So सब aspirants को use होगा. So please all of you try to help the instrumentation friends also. Okay? Sure Shubham. Thank you very much. Tata, bye bye. Love you all. So great love from Gate Academy. Okay na? So utilize the service of the Gate Academy. चलो आपका कमेंट्स देख रहा हूँ. नाइस इंटरेक्शन शुभम, नाइस इंटरेक्शन राहुल जायसवाल. आई होप ऑल ऑफ यू आर गेटिंग बेनिफिटेड बाय दीज सेशंस. ओके ना? प्लीज इनिशिएट टू मैक्सिमम इंस्ट्रूमेंटेशन टीम सो दैट दे ऑल गेट बेनिफिटेड. Thank you very much. Riya Tiwari, you please inform from, there are so many friends here from Kolkata, from Bangalore, from Chennai and from Andhra Pradesh, from Tamil Nadu, from Karnataka, from Assam. कोलकाता से बहुत अच्छा दोस्त आया, गौरव कौर आया. ओके, थैंक यू वेरी मच. थैंक यू. इनिशिएट शुभम, एक क्वालिटी कंटेंट मिल रहे हैं ना आपको, सबको क्वालिटी कंटेंट आ रहा है. सो क्वालिटी मार्केटिंग कंटेंट नहीं है, क्वालिटी कंटेंट आ रहा है. ये कोर्स होने के बाद मैं ऑप्टिकल भी स्टार्ट करूंगा, ऑप्टिकल के बाद मेजरमेंट्स भी स्टार्ट करूंगा. अगर मैंने बायोमेडिकल का स्टूडेंट से रिस्पांस आया तो मैं बायो सेंसर्स भी स्टार्ट करूंगा. I am from Hyderabad. कोलकाता. I am from Hyderabad. या इंस्ट्रूमेंटेशन का लोग कॉर्नर्स में होता है. We are rare diamonds. We are not like a coal. We are rare diamonds. Okay? So नूकों कॉर्नर में होता है. देश के नूकों कॉर्नर्स में, आसाम में, तमिलनाडु में, पांडिचेरी में, हैदराबाद में. Yes or not? चलो, bye bye. I am closing the session. Take care all of you. Love you all. Every time I am telling, please stay at home, take some safety measures, take proper vegetarian diet and take hot water, do some breathing exercises, take care of yourself, take care of your family, take care of your parents. Okay na? So don't take any risk, avoid all going outside, stay at home, prepare well, be safe. बाय टू ऑल। डन, ऑल द बेस्ट। फिर मिलेंगे ऑन वेंसडे, विल मीट ऑन वेंसडे, विल मीट ऑन वेनसडे, ओके ना।